Pythagoras was a philosopher in ancient Greece who lived in the 6th century BC. He studied astronomy, mathematics, music, and religion, but he is most well known for his famous theorem, Pythagoras' theorem. Pythagoras was known to provide a proof for the theorem that bears his name, and methods to find Pythagorean triads, which are sets of 3 whole numbers that make up the sides of right-angled triangles. So Pythagoras' theorem is all about right-angled triangles and their sides. His theorem states that the square of the hypotenuse of a right-angled triangle is equal to the sum of the squares of the other 2 sides. In other words, if you take the 2 shorter sides, measure their lengths, square each of them, and then add those together, you will actually get the same value as if you just took the hypotenuse and squared that. So algebraically, it looks as if the sides of the triangle are A and B as the 2 shorter sides and C as the hypotenuse or the longest side, then C squared is equal to A squared plus B squared. A Pythagorean triad is a set of 3 integers, whole numbers, which satisfy Pythagoras' theorem. So Pythagoras' theorem states C squared equals A squared plus B squared. So let's consider if these 3 numbers are a Pythagorean triad. To do that, we first of all work out which is the biggest number, which is 10, and we'll call that C. So C squared is 10 squared, which is 100. The 2 shorter sides we'll call A and B. It doesn't matter which one's A and which one's B, we just need to make sure that they are the shorter sides, or the smaller numbers in this case. So we'll work out what A squared plus B squared is. 6 squared plus 8 squared. 6 times 6 is 36. 8 times 8 is 64. 36 plus 64 is 100. So we see we get the same value regardless of which combination we use. Therefore, 6, 8, 10 is a Pythagorean triad. What about this combination of numbers? Four, 5, and 8. Again, let's have a look at the biggest number. 8 squared. 8 times 8 is 64. Let's look at the 2 smaller numbers. Doesn't matter which order I put them in. I'll keep them in the same order though. 4 squared plus 5 squared. 4 4s are 16. 5 5s are 25. 16 plus 25 is 41. They are not equal to each other. Therefore, 4, 5, 8 is not a Pythagorean triad. So a Pythagorean triad is simply a combination of 3 numbers that satisfy Pythagoras' theorem. We can use Pythagoras' theorem to decide whether or not a triangle is actually a right-angled triangle without having to draw it to scale, without having to build it. What we do is we look at, much the same way as Pythagorean triads, we're asking, are these three numbers a Pythagorean triad? So, again, we'll start with the longest side, because if it is a right angle, that's going to be the hypotenuse, because the hypotenuse is always the longest side. So let's consider that. C squared is 9 squared. 9 times 9 is 81. Now let's consider the two other sides. A squared plus B squared. I'll use them in order left to right, though I could use them order right to left. 4 squared plus 7 squared. 4 fours are 16. 7 sevens are 49. 16 plus 49 is 65. These two numbers are not equal. So C squared does not equal A squared plus B squared. Therefore, the triangle is not right-angled.